This video is going to pick up where the EOQ video for the Inventory2 file for product L left off and look at combining the EOQ with a 95% service level target. So we need some additional inputs. We need to have the mean lead time and the standard deviation of lead time. So we have a sample on the LT tab here, which was taken from the product sales data of lead times for all these products. So one way to make sure we calculate this correctly would be to use a simple pivot table. So we'll insert a pivot table. And in this case, I think I'll just place it in the existing worksheet and choose a location up here at the top. All right, and so all we need to do here is we'll filter this on product. And for the values, we'll have the lead time. And then instead of the sum of lead time, what we'd like is the average. So we'll just change with the down arrow the value field settings and calculate the average. Now we also want the standard deviation, so let's drag LT again and then again change the value field settings and scroll over here and find standard deviation. Okay, now the only thing we need to do now is just limit this to product L. All right, so we've got 12.22. And then 1.48. Okay. So now what we need to do is calculate the mean lead time demand, and that is basically the mean daily demand times the mean lead time. Now we go ahead here and just use the round function because for what we're doing with expected shortage later, it's just easier to round that to an integer. Our standard deviation of lead time demand is already calculated. And then our effective maximum is the mean plus 3 times the standard deviation. The 3 is because we're going to assume that the normal distribution captures almost all the probability within 3 standard deviations of the mean. Okay, now we're going to start out with a 95% service level target. We can certainly change that and try other targets, but that's what we'll try first. Right now we're not using a fill rate target, so we'll leave that. What we're going to do is set the reorder point somewhere between the mean lead time and the effective maximum. So these are actually really large numbers, so let's just try 2,000. That's a number that's in that range. That's just a starting value. Of course, we're going to use solver. And so then the safety stock would be the reorder point minus the mean of lead time demand. Okay, now the service level then is the area under the normal distribution, norm.dist, when we consider the reorder point and the mean and the standard deviation, and then we want the cumulative probability all the way up to the reorder point, so that'll be 1 for cumulative. Now, we're going to fill in this value on line 28. It'll actually be important. We'll explain it later. But we're going to fill this in with a function called the mod function and put the reorder point and the order quantity there. And we'll explain that in class later, and it's explained in the textbook also. All right, so we've already got the ordering cost calculated. Now that we're considering reorder point and safety stock, we need to consider the holding cost for the safety stock. So we'll just reference the safety stock here, and then we'll just add it to this holding cost function. And we'll also calculate holding cost on B36, which is the safety stock. And our function here will go ahead and add that in to the annual inventory cost. So we should be ready to adjust our solver to find this order quantity and reorder point. So let's go to solver. It was set up for the EOQ. The objective is still the same. Notice that we have added the safety stock cost in there to the holding cost. But now we're going to adjust two things. We're going to adjust the order quantity and reorder point. We had a constraint in here that Q is greater than or equal to 1. We're also going to have a constraint that the service level is greater than or equal to the desired service level, which is 95%. We can also have, if we want to, two more constraints on the reorder point which will help, and that would be that the reorder point is less than or equal to the effective maximum, and the reorder point is greater than or equal to the mean lead time demand. And so we have our solution. So our solution is we still have an order quantity of 801. Notice this is still the economic order quantity. We have a reorder point of 2090. It's a large reorder point, and we need to discuss what happens when the reorder point is greater than the order quantity, but we'll do that. That will involve this line here, remaining when ordered. The safety stock is 352. Our fixed ordering costs are 10,649.61. That's the same as the EOQ. And then our holding costs are higher because our holding costs also capture holding costs for the safety stock. And let's see, our holding cost here may not have been correct. That should be so our total inventory cost for EOQ should be $21,299. And then our total holding cost plus ordering cost here, now that they're capturing the safety stock, are significantly higher. We don't have expected shortage costs yet. We're not considering them because we're considering customer service through this 95% service level target. So of course our service level, as calculated over here, is 95% at the optimal solution. Let's just type that in. Made a correction here for this formula to be consistent for both columns. So that would be how we would incorporate the service level target with the economic order quantity.